I'll be honest with you, when I first dumped crushed rice into my garden beds, my neighbor looked at me like I'd completely lost it. But 6 months later, when I pulled back the mulch to reveal a writhing mass of earthworms 3 times denser than my control beds, that same neighbor was suddenly very interested in my crazy experiment. Today I'm sharing everything I learned from this wild ride, and trust me, the results are going to change how you think about feeding your soil. Let me take you back to where this all started. I was standing in my kitchen, staring at a 20-pound bag of broken rice I'd bought by accident. You know, the stuff that's too shattered to cook properly. My frugal gardener brain immediately kicked in. Rice is pure carbohydrate, I thought. Soil microbes love carbohydrates. What if I could turn this kitchen mistake into black gold for my garden? I'd been reading about how high carbon amendments can jumpstart soil biology, but most advice focuses on wood chips, straw, or compost. Nobody was talking about rice. That's when I decided to get weird with it. I set up 3 identical raised beds with the same soil, same plants, and same watering schedule. The only difference: bed 1 got nothing special, bed 2 got standard compost, and bed 3 got my crushed rice treatment mixed into the top 4 inches of soil. Here's exactly what I did, because I know you're going to want to replicate this. I took that broken rice and ran it through my blender in small batches until it was roughly the consistency of coarse cornmeal, not flour fine, but definitely broken down. This step turned out to be crucial, and I'll explain why in a minute. For each 10 square feet of bed space, I worked in about 2 cups of this crushed rice, mixing it thoroughly with the top layer of soil. I didn't just sprinkle it on top because I wanted it integrated where the real microbial action happens. Then I watered it in deeply and topped everything with 2 inches of wood chip mulch to keep moisture levels steady. The timing matters too. I did this in early spring when soil temperatures were consistently above 55 degrees Fahrenheit. Below that, and the microbial activity you're trying to stimulate just won't kick into gear fast enough. The first 3 weeks? Honestly, not much visible change. This is where most gardeners would panic and assume they'd just wasted perfectly good rice. But here's what you need to understand about soil biology. The magic happens underground before you see anything topside. Around week 4, I started noticing something interesting. The soil in my rice bed felt different when I stuck my finger in it. It had this almost fluffy quality, like it was breathing. The control bed still felt dense and compact in comparison. When I dug down about 6 inches with a trowel, I found my first clue that something special was happening. The rice particles I could still identify were covered in what looked like white fuzz. That was mycelium, the fungal network that's absolutely essential for healthy soil structure. The plants themselves started showing subtle differences too. The tomatoes in the rice bed had noticeably darker green leaves, and the pepper plants were putting out new growth faster than their counterparts in the other beds. Month 3 is when things got absolutely wild. I was installing some drip irrigation and had to dig shallow trenches across all 3 beds. When I lifted the soil in the rice bed, I literally gasped. Earthworms everywhere, not just a few, we're talking dozens in every shovelful. I actually counted them because I'm nerdy like that, and the difference was staggering. The rice bed averaged 27 earthworms per cubic foot of soil. The compost bed had a respectable 12 per cubic foot. The control bed? A measly 9. That's a 3-fold increase in earthworm population in just 90 days. These weren't baby worms either. They were fat, healthy, active earthworms doing exactly what we want them to do, aerating soil, creating channels for root growth, and leaving behind nutrient-rich castings. Here's why I think this happened. The crushed rice provided an immediate, easily accessible carbon source that fed bacteria like crazy. Those bacteria became earthworm food. But more importantly, the fungal networks that developed to break down the rice created the kind of soil structure earthworms absolutely love. It's like I accidentally built them a 5-star restaurant with perfect ambiance. By harvest time, the differences were impossible to ignore. My tomato plants in the rice bed produced 40% more fruit by weight than the control bed, and 22% more than even the compost amended bed. The tomatoes themselves were larger, and here's the kicker, they tasted noticeably better. Sweeter, more complex flavor. My theory is that the enhanced fungal network was facilitating better nutrient uptake, particularly of micronutrients that contribute to flavor. The pepper plants told an even more dramatic story. In the rice bed, I harvested peppers a full week earlier than the other beds, and the plants kept producing 3 weeks longer into the fall. The root systems, when I finally pulled the plants, were absolutely massive compared to the control group, easily twice the size with that beautiful white color that indicates healthy, active roots. Let me break down what I believe is happening at the microbial level, because understanding this will help you adapt the technique to your own garden. Rice is almost pure starch, which breaks down into simple sugars relatively quickly. This creates a microbial feeding frenzy, particularly among bacteria. As bacteria populations explode, they consume nitrogen from the soil. This is that temporary nitrogen tie-up you hear people warn about with high-carbon amendments. But here's the thing. I crushed the rice into small particles. This meant it broke down over weeks, not months, so that nitrogen tie-up was brief and mild. By the time my plants were in their heavy growth phase, the bacteria were dying off and releasing all that nitrogen back into the soil, along with other nutrients they'd immobilized. It created this beautiful slow-release effect. Meanwhile, fungi moved in to tackle the more complex carbohydrates. Fungal hyphae create the soil structure that holds water and air in perfect balance, exactly what plant roots crave. This 1-2 punch of bacterial then fungal activity transformed my soil texture in a way that typically takes years of composting to achieve. Start small. Seriously. 1 bed or even a large container is plenty for your first experiment. Use about 1 cup of crushed rice per 5 square feet of growing space. If you're working with heavy clay soil like mine, rice can help break up that density. Sandy soil will benefit from the structure that fungal networks provide. Timing is everything. Do this at least 4 weeks before you plant anything heavy feeding, or, just apply it in fall for spring planting. If you're adding it to established beds, keep it to the outer edges away from plant roots for the first few weeks while the initial microbial boom happens. And hey, don't skip the crushing step. Whole rice grains take way too long to break down and can cause localized nitrogen depletion that'll hurt your plants. You want a texture that'll break down in about 4 to 6 weeks, not 4 to 6 months. I'm writing this article after a full growing season, and honestly, the rice beds are still outperforming everything else in my garden. The soil structure has remained phenomenal, loose, crumbly, and just teeming with life. I've actually reduced my watering by about 30% in these beds because they're holding moisture so much more efficiently. The earthworm population has stabilized rather than continued growing exponentially, which, makes sense. They've reached the carrying capacity for the available food and space, but they're maintaining those higher numbers, which really tells me I've genuinely shifted the soil ecosystem into a more productive state. If this experiment has inspired you to think differently about soil amendments, I'd love for you to subscribe to the Soil House channel, where I'm constantly testing unconventional methods to build better soil. Drop a comment telling me about the weirdest thing you've ever added to your garden. I'm always looking for the next crazy experiment, and if you know a fellow gardener who'd benefit from this information, share this article with them. Let's build better soil together, one weird experiment at a time.